Welcome back. In this third and final session on philosophy of science, I'm going to take up the question of theory choice and how do we know that one theory or one explanation is better than another theory or another explanation. So this question has a long history. The philosopher Karl Popper argued that a critical feature of theories is that we should make them falsifiable. We should make theories that have falsifiable observable implications, and that it's the failure to falsify theories that constitutes some form of progress. This is often referred to as the falsificationism approach to thinking about progress and choice among theories. The problem with this view, or one of the problems, the key problem, is that when a theory fails in making a prediction or explaining a case, it's not always clear if it's the theory that failed, or maybe some weird thing was going on, or maybe there was some measurement error or something else. This is known as the Quine-Duhem problem after two different philosophers of science. And so it's not always clear that we should throw out a theory at the first problem or anomaly. And indeed, when we look at the history of science, scientists don't usually throw out long-established theories when they don't fit one experiment or one case. They usually look first for some flaws in the measurement or flaws in the experiment. So Thomas Kuhn looked at the history of science and extended this argument further and said, really, competing theories aren't fully commensurable. They don't all really fully address the same set of issues. And so it's not obvious, when theories of failure to explain some problem means that the other theory is necessarily better. And so he famously argued that there's no higher standard for theory choice than the agreement of what he called the relevant scientific community. Now, there are many critics of his view because this seemed to throw all of science just into whatever scientists thought was right or thought it was. It's way too relativistic and sociological for many people's tastes about what they think that science is. At the same time, it's more neglected in Kuhn's work, but while he still said that it's the assent of the relevant scientific community that matters, he also said that it makes a great deal of sense to ask which of two theories fits the facts better. So it's hard to reconcile those two views in Kuhn. The one seems very empiricist and the other is very sociological notion of whether and how science progresses. So Imre Akatosh, who was sort of a part-time philosopher of science, I believe is a mathematician mostly, he was very uncomfortable with Kuhn's argument. He thought it made science way too relativistic and soft, but he also was wary of what he called naive falsificationism, the Popperian idea that you sort of throw out a theory at the first anomaly, because clearly that wasn't empirically true, and Kuhn, Lakatos wasn't convinced that it was logically justified to throw out theories at the first anomaly. So he wanted to find a way to assess whether theories were progressive and improving or not that was rigorous and not too dependent on just the willy-nilly views of a few different scientists. So he wanted to find methodological criteria for a more sophisticated form of judging theoretical progress. So he argued that the choice between comparing theories or explanations is not made by simply falsification or one test or one anomaly, but it's a series of tests over time and a series of anomalies or growing anomalies that lead us to move away from one theory and towards some alternative. And we don't we don't throw out a theory unless there is an alternative. Scientific progress is a three-cornered fight between two theories, at least two theories, and the evidence. If there's only one theory, it's the best theory in town until another different theory comes along. So he also argued that choice between theories proceeds not just by falsifications, but by confirmations of their predictions and expectations. Now, he said that the choice between theories should be made on the basis of what he called novel facts. Now, he didn't define novel facts as tightly as we might like, but this was the idea that theories would lead to a series of some facts that were in some sense novel or new, and that those theories would be judged progressive, and the ones that face growing anomalies would be judged regressive. But later, people, in particular Colin and Miriam Ellman, have come up with a more clear discussion of different kinds of novel facts, and there are two kinds in particular that we want to focus on here. One is what we call background theory novelty. This is the idea that if a theory says it explains some outcome or some process, and no other theory says it has an explanation for that, well, then the first theory, by definition, it's the best theory, right? We sometimes talk about inference to the best explanation, and when there's only one candidate explanation, well, that's the best explanation in town. So an example here would be when Einstein came up with his theory of relativity, there was something that was already known to be an anomaly for Newton's theory, which was that the orbit of Mercury around the sun did not fit the predictions of Newton's theory. So Einstein knew this already, but it turned out that the mathematics of Einstein's theory fit the orbit of Mercury, and so this was taken as a strong support for Einstein's theory because it was the only theory that had some plausible argument that it was consistent with the orbit of Mercury, right? So this is background theory novelty. The other kind of novelty is what we call use novelty. Use novelty is when we have a theory that explains some facts or outcomes that were not already used to create the theory in the first place. This could be a prediction about an event that hasn't happened yet, or it could be a prediction about some evidence that hasn't been looked at, even if the evidence is in the past. So, to take another example from Einstein's work, Einstein's theory of relativity suggested that if we could measure the light of distant stars as that light traveled close to the sun, we would see the gravitational field of the sun actually pulling that light towards the sun. Again, this was not consistent with Newton's theory, so it had background theory novelty as well as use novelty. It had use novelty because nobody had ever before measured whether light bends toward the sun. Indeed, the only way you could measure that is during an eclipse, because otherwise the light of the sun, is too bright for you to see the light of distant stars. So in the solar eclipse of 1916, scientists at different points on the Earth took photographs of the light of distant stars as that light went close to the sun, and indeed those photographs suggested that the measurements were more consistent with Einstein's theory. And so this was also taken as a strong confirmation of Einstein's theory because it was something that was not known for certain and had never been observed before. And to be consistent with that was quite a strong demonstration in support, sort of confirming the theory. So you will often hear that you can't create a theory from a case and test it against the same case. And the idea behind that or the idea that leads to that is some emphasis on this idea of use novelty. But I would say that's wrong. I would say you can develop a theory from a case and test it against different evidence in the same case, because that evidence still may not have been examined before. You may not know the value of that evidence before you observe it, right? Now, we'll see when we talk about Bayesian process tracing that some Bayesian process tracers, notably Tasha Fairfield and Andrew Charman, think that actually it doesn't matter if you knew the evidence already when you came up with the theory. It just matters whether that evidence is likely if the theory is true, and whether that evidence is likely if alternative explanations are true. We'll come back to that argument and explain it. Now, just to preview a little bit more, I would say that a lot of people have the intuition that there is a difference between evidence that you already knew what it was and evidence that you didn't know what it was. And I think there's a logical and there's a psychological explanation for that intuition. The logical argument for it is that if a theory was built around evidence we already knew, then that evidence can't be inconsistent with the theory. It can't test the theory, right? In Bayesian fashion, we'll see there is an argument you're still, in some sense, testing the theory. But the psychological argument is that because of all the ways we're prone to confirmation bias, that if we know about the value of evidence already, there's subtle ways that we'll sort of treat that as if it's a confirmation of the theory, when really we may be just, fitting the theory around the evidence, or what sometimes we call curve fitting, right? So my argument, which is a little bit different from Fairfield and Charman, again, we'll come back to this, is that probably there is still some psychological difference between evidence we already knew what the evidence was versus evidence that we only discovered after we thought to look for it, and after we'd already specified how likely was that evidence if this theory is true or if an alternative explanation is true. We'll come back to that issue, but I just wanted to preview it here. Okay, now the reason that I emphasize these two kinds of novelty, and especially the second kind, is that in case study research, we're often trying to test different explanations against evidence in a case, and there's going to be lots of evidence in a case that we don't know beforehand what that evidence will show. There's going to be lots of details that even people who were participating in the case, even people who studied closely, may not know all of the details of the processes in that case. And so there may be lots of evidence in the case that can be still independent in the use novelty sense, right? So I'll come back to my statement that often we can develop a theory or an explanation from evidence in the case and then test it against different and independent evidence in the same case, right? Or again, we could even make an argument that we could still test it against the evidence that gave rise to the theory in the first place if that evidence is unlikely to be true under the alternative explanations. That's the sort of objectivist Bayesian view versus the more subjectivist Bayesian view, which still puts some value on use novelty. We'll come back to that when we talk about Bayesian process tracing. Okay, let me close then with just coming back to some of the postmodern critiques of progress and of theory choice. And you might, at the end of the video, if you're taking a course with me, you might write down some notes or questions you have on this or any other parts of this presentation. So one critique is that observation is theory-laden, right? We have theories in our heads that literally sort of shape what we can see and perceive in the world. And there's lots of psychology experiments that show that that's true. And it is true, right? At the same time, I think the short counter-argument is that observation is not theory-determined. There will still be things in the world that will surprise us given our theories, and we will experience that feeling of surprise, and we can use that to explore something that doesn't fit with our theoretical expectations, right? So there are some aspects of social relations in the world that are independent of us as observers, and we can recognize those things because they're different from what our mind led us to expect, right? The second critique of theory testing and ideas of progress is that theories and language are open to many different interpretations. And I would say again, yes, that's true, but even people who make those arguments often act in their own lives, in their own personal lives and in their scientific or productive lives, as if some explanations are better than others, right? And they may have some ideas for judging when some interpretations, or if you will, explanations, are better than others. And so I would say we do have some ways to judge this issue, not perfectly, right? But we can make some claims. Use novelty and background novelty are two standards I've given you for judging progress in theories. We'll see that the Bayesian logic also gives us a way to judge alternative explanations. A third critique is that theories and science reflect power and social power as well as evidence. And that's true, right? So some kinds of research get funded, other kinds of research doesn't. And powerful, wealthy actors may have a lot of influence over what gets studied and what doesn't. At the same time, my response to that would be, we know that, and we can still study that. Even when we don't have a lot of funding, we can study relations of power. And sometimes we will get funding to study relations of power. Indeed, relations of power are one of the most studied things in all of social science. So yes, we can be conscious of that, and we can try to correct for that as best we can. We're not totally helpless here. And then the final critique is that agents and structures may be mutually constitutive, may be endogenous all the way down to even small slices of space and time. Again, that can be true, right? But I would still argue that social structures are sufficiently long-lived that we can usefully study them and we can usefully make claims about them and we can hopefully influence the progress of society for the better for all individuals, right? Notice that there's a kind of a tension between claiming that, science is so infused by social power that it can't cast a light on social power, and saying, everything is up for grabs all the time, agents and structures are so mutually constitutive that sort of anything could happen. Well, those can't both be true. If we have structures of power in society, and we do, they will be lasting, they will reproduce themselves over time, and we can study them. Maybe not, we can't make claims for all time because institutions change, right? Even the biological nature of humans has changed, evolved over time, right? But we can make claims for pretty long periods of time because the institutions and human biology don't change that fast. And so I don't aspire to make predictions or explanations for all of time, but for very meaningful periods of time. Okay, let me end with some implications for case studies. Process tracing relates to the study of causal mechanisms and how they operate in individual cases. We'll unpack that a lot more when we talk about process tracing. This uses, I would argue, a Bayesian logic. We'll say a lot more about that down the road. Some advice about how to do research that emerges out of a statistical approach and statistical mindset does not apply to case studies. So advice like do not study single cases does not apply. There's a lot you can learn from single case studies. Claims like do not select on the dependent variable, often for a very good reason. We select partly on our knowledge of the dependent variable in case studies. There are reasons you wouldn't want to do those things in statistics, and they're very good methodological reasons. They don't apply to case studies, or at least not in the same way, right? So these are not absolute rules for case studies, right? And I would say these criteria of background novelty and use novelty are useful in case studies. They help discipline us from succumbing to confirmation bias, and they're useful in carrying out process tracing tests, although we'll see there's some disagreement even among Bayesian process tracers, of whom I consider myself one, about whether use novelty is really a useful or essential criteria. So I think finally we need to address the critiques made by postmodernists, but we shouldn't be paralyzed by them. They don't take away all the prospects for progress or science. And indeed, when you read a lot of interpretists like Clifford Geertz and others, they may use different language, but I would say they're actually making arguments that some explanations are better than others, and there are ways to assess that and to test that, and that there are some ideas of progress in our understanding of the social world. Okay, let me stop there. If you're taking a class from me, take a few minutes and write down any questions you have that we can take up when we interact with each other on whether it's in person or on Zoom.